All right, so are you trying to get back on your, can I get your attention if at all possible? Please, please, and thank you. Are you getting back on quadratics? Everybody say quadratic.
Quadratic.
What does quadratic mean to you?
4 steps.
4 steps? What kind of steps?
Foil.
What about the steps?
Foil.
Foil? Tell me more about foil.
First inside. Wait. First outside, inside last.
Yes? What kind of steps? Be more specific. What are the steps doing? What happens in the steps?
Parentheses down. And
Parentheses?
What are you doing? You're like something with like a binomial.
A binomial? Nice. Everybody say binomial.
Binomial.
Right? Can you picture it in your mind? Can you picture a binomial in your mind? How many pieces are in a binomial? Laura, can you picture one? Are you with me? Are you giving me your attention? Are you coming back? 2. And what are they within? Can you picture a binomial in your mind? So I think that's your challenge, right? You know how our brains are. What do our brains do with stuff that's not useful to us? Forget it. Yeah. I always say we're like, our brains are very efficient. They flush anything we don't need on a real-time basis. You with me? Our brains are like that. It's a real blessing, and if you think about it, because we take in so much input all day. If our brains kept everything we took in, it would be a disaster in there, right? So it's a good thing they flush things. But in your classes like this, you're trying to remember those relevant ideas, right? So let's go through. Do you remember the shape that a quadratic produces when it graphs?
A U.
A U. I would love it if your vocabulary was more specific on an algebra basis.
I don't know what this is.
A parabola.
Oh, parabola.
Everybody hear it? Everybody say
got it.
parabola.
A parabola.
Right? Are your brains warming back up? You know what's interesting about your brains? They have to warm up. Are you with me? Do you hear them? I can almost hear your brains warming up. A parabola. Can you tell me any parts of a parabola? Vertex. Everybody say vertex.
Vertex.
Okay, draw the parabola in the air with your finger. Everybody, try it. Try it. Do it. Work with me. Go. And I actually saw one person go like this, but I don't know if you did that on purpose. Did you go like this? Because is this a parabola? Sure, it can be upside down, right? If you put a negative in front of the x squared, it flips it, and now it's an upside down u. So u is right. I'm okay with this, right? I'm okay with your brain going, it's a u. You got to start somewhere, right? And then fill in the gaps. But your brain also should know that the u could be put upside down, right? It could be I don't know what that is, a hill or a bump, or I'm not sure what, right? Are you with me? You did that on purpose? Thank you. Thank you for that very much. Okay, so you've got parts of the parabola. Can you think of the name of the places where the parabola crosses the x-axis? Okay, draw an x and y axis in the air. Draw an x and y axis. Okay, good. And now draw the parabola going across it. Do it this way, right? Can you see it crossing the x-axis in your mind?
Yeah.
Those points where it crosses the x-axis or intersects them, can you come up with some of the names for those? Somebody said roots. I'm not sure which one of you. Roots and x-intercepts. Everybody say roots.
Roots.
X-intercepts.
X-intercept.
Do you see how you're filling in the whole topic here? The whole topic is in your brain. It's not unknown to you. Are you okay with this? You just have to be able to refresh all these ideas in your mind, right? You're going to put a lot of stuff into your minds over the years and flesh it back out and put it back in and flesh it back out. You with me? Your brain's very flexible like that. It's awesome for that. Okay, so you said roots, x-intercepts. There's a third name. I feel like I want to give you bonus points if you can come up with a third name for those points. Okay, I want you to think about it. Here's the x-axis, right? And here's the parabola, and it's crossing. If there's 2 points, it's crossing. Now.
The zeros.
Oh, did you look it up here?
No.
It is. It's the zeros.
Because I was thinking about it.
Sorry to interrupt.
What's that?
I'm sorry to interrupt.
Okay.
I just have a note for
For?
some other kids. I'm not
Okay.
taking them, I'm just delivering it.
Okay.
Can I just give a quick intro?
Okay.
If you're receiving this note, that's because you get to have a table tomorrow at our exhibition. We're gonna share your personal project. So just read the note, tells you what time to come.
Okay.
And this will be your pass tomorrow.
Okay. Thank you, thank you. Thank you so much. Okay. All right, well, let's go with this lesson before I lose too much time and there's too many more interruptions. Let's look at the parabola. So,
Why is it always called the zeros though?
good question. Okay, to get me back on track, why is it called the zeros? Now you should really get bonus points if you can remember this part of it. Why is it called the zeros? It's in there. There's a reason for this. You know, a lot of times in math, I feel like we don't have really good reasons for things that are explained by the names. But in this case, the name really does explain what's happening. Zeros is a good name. Let's see if it's in my lesson for today, why it's called this, and let's see what we can do. Because I want to stay, today's lesson is on the vertex again. And I kind of want to focus on that for the minute. I want you to keep that question. We're going to go back to it, okay? I don't want to answer it right now. It is in your notes and we have covered it before, all right? But let's go for today's topic, the x location of the vertex. Okay. The x location of the vertex is given by, or found by, I'm not sure about the wording, is given by negative b over 2a. All right, first things first. The language is always very thick and dense in math, right? What does an x location mean? When you're graphing, draw that x and y axis again. Draw your x and y axis in the air. Draw that, draw that. What's an x location? It's the value on the, because the x is a number line. Remember number lines you started with? That was very beginning, way back in elementary school. They said, here's a number line. Which one did they give you first? The x. And then later they said, hey, that's one dimensional. Now we're going to make it two dimensional. So they gave us what number line now? The y. It's just a number line too. It's just vertical. And then there's a third number line when you get into 3 dimensions. That number line, you know, it's x, y, and what's the other number line?
Z.
It's z. Finally, things that make sense. It's x, y, and z. Those are the 3 dimensions. You with me on that? Okay. So, with this said, the x location is going to fill in that idea of x, y, and z. Those are locations on this graphing system that allow us to put things into places. Fair enough? All right, the vertex. Do you know what that is of the parabola? On the parabola, draw the parabola in the air and then point to the vertex. Yep. Yep. Draw the parabola in there. Are you seeing it in your mind? You're doing it in your mind? Okay, fair enough. If you see it in your mind, I'll take you up on that too. Right? Okay, so that's what we're talking about here, and we'll show it in a second as we get through this. Let's deal with the first example. Given f of x equals. So if we have f of x equals an x squared plus 6x minus 27. All right. What's a in this case?
Oh,
What's a in this case?
1. So 1.
It is 1. Oh, here we go. Oh, that's awesome. Who doesn't know why it's 1? Raise your hand if you don't know why. Be honest, be honest. If you don't know why, raise your hand. Nobody can see you, nobody at all me. Okay, good. I appreciate your honesty. But I want you to think about it. I want you to figure it out. Okay? Tell me what, somebody who knows what we're talking about right now, tell me what B is. What is it? 6. Okay, now those of you that raised your hand, you said, I don't know what A is. Now that you see B, can you figure out where A is coming from? Well, let me show you, let's do one more. Do one more. I want you to figure it out. If you can figure it out, then this is all fine. You with me? That's the whole point. There's a lot of stuff you don't know in life, but if you can figure it out, everything's fine. There's no problem, right? You can just go back and figure it out. So C. Who knows what C is? Negative 27. Are you seeing a pattern? So Andrea, can you explain where the 1 comes from for A? in front of the x. How come I don't see it? It's what? It's invisible. Everybody say invisible. Not only is math difficult, but we have invisible things going on, right? So you have to know enough to know there's invisible. There's 3 invisible ones on everything. Here's an x squared, all right? Well, let's deal with just an x. Where's one invisible one? Right here. 1 times the x, invisible. We don't show it. Why bother? But it's there, and you need to know it's there all the time. All right, where's another invisible one? It's always being divided by that. So is the x in the numerator or the denominator position? Numerator, always. Are you with me? Everything's a fraction you're dealing with all the time because there's an invisible one down there. You just aren't seeing it as a fraction, but it is, right? If your brain can sort of see that, then you're much more flexible dealing with all this situation, right? Where's the other invisible one? On here. There's a power 1 always on everything. If it was a 5, same thing, 3 invisible ones. I do a lesson in here called 3 invisible ones, because if you can remember they're always there, it helps you just figure out what's going on. There's a 1 times this, and that's what a is. It's the coefficient in front of the x squared. And here's the generic, f of x equals ax squared, the value or number coefficient in front of the variable, plus bx plus c. This is the generic, so whatever value is here with its sign, right, goes here, and whatever value this constant is here hanging on with its sign, that's ABC. Fair enough? Okay. Pretty simple once you see it. You're gonna forget it. You need to just go back and figure it out each time. At some point you're gonna be in college and you're gonna Google stuff. You know, the hardest thing is remembering some names to start with. What I even call it, right? Type in quadratic, then you'll type in something else, then you'll type in something else. You can refresh all your brain and all your memory on all the topic. All right, so with that said, we want to find the x location of the vertex. So see this idea? X is equal to negative b over 2a. X is equal to what? What do I write in the numerator position?
6.
Close.
It's not 6?
It is 6.
Oh.
More.
6.
The formula has within it this.
Oh.
So if this is positive, we're going to write negative 6. If this was negative, because there's a negative in the formula, we would have had to reverse it. Fair enough? And it would have become positive. Okay with that so far? Okay, what do I write on the bottom? What do I put in the denominator position now? Yeah? No? This one's the no? Okay, look, here's what we got. 2 times a. What's a?
Oh, 1.
2 times 1. What is negative 6 divided by 2? You okay with that? 6 divided by 2 is 3, and there's a negative divided by positive is negative. Fair enough? So the x location of the vertex of this parabola is negative 3. All right, how do we find the y value? We take this and say y equals the entire thing we started with, the quadratic we're given, x squared plus 6x minus 27. And now we're going to say y is equal to, and we plug in the value of the x. In this case, it's negative 3. So negative 3 squared plus 6 times negative 3 minus 27. What is negative 3 to the power 2? Help me out here. What's negative 3 to the power 2? Are you starting to break out your calculators in case you can't do it in your head? And we're going to break out Desmos real soon too and just graph it, right? Because we want to confirm our location of the, but I don't want to tell you Desmos too much because I want you to do the vertex first and then I want you to check it on Desmos with me. I know you can look up Desmos, just find it right off, right? But you should be able to calculate it. So, okay, what's 3 squared? So careful here. 3 squared, so negative 3, because it's in the parentheses, becomes negative 3 times negative 3. Y equals 9. You okay with this? 3 times 3 is 9. Negative 3 times negative 3 is 9. Because negative times negative is a positive, right? 2 negatives, all right? So What's this right here? What's 6 times negative 3? What's 3 times 6? 18. What's 6 times negative 3? Are you saying negative 18? So get rid of this plus and put minus 18. Minus 27. All right, what do you want to do first? All the negatives? The two negatives together become 30, 45. Are these two together negative 45? So you're way down at negative 45, but you get to come back up 9 because it's positive, right? So negative 45 would be 9. Negative 36. Are you checking me? So now we have an x location and a y location. I'm trying to see where my lesson went to see if I'm off track or not. Oh, I only used these. I didn't even do the vertex on these. I just used them to practice the A, B, and C. Fair enough? So in the lesson, I gave you 1, 2, where I just said just plug in A, B, and C to practice the A, B, and C thing, right? What we did right here. We practiced A, B, and C. We're just going to the next step on this one and finding the vertex. I didn't do it on this lesson. Do you have Desmos up right now? So here's our graph right now. We have an x value of negative 3, 1, 2, 3, and we have a y value of negative 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, can I be down here at negative 36? It's not exact. Somewhere way down here. Okay, are you on Desmos? Did you pull it up on your screen? Go to desmos.com. Go to desmos.com. Go to desmos.com. And start to type this in. Type in f of x equals, and let's at least check our math on the vertex. Are you trying it? Are you trying it? One more, are you trying it? Can you hear me? Are you trying it? Go to Desmos, go to Desmos. Okay, who's there? Yep, click graph. You can either say f of x equals this, or you can say y equals this. This is the graphing notation or our standard Cartesian coordinate plane system. This is the function notation, f of x. Everybody say f of x. Because that's how you say this, right? This is f of x, just so you remember. I know we've covered it, but just remember the... Okay, and click way down there and tell me what... Did you click? What's it say? Right? And so way down here, the coordinate notation is negative 3, comma, negative 36. That's the location of this thing. Can you tell me where the roots are? And let's just finish that up quickly. Where are the roots? Click on where it's crossing the x-axis. 0 and what? No, I don't think so. Oh, got it. No, yes, good. That sounds good. Click up here on these, click there.
Negative 9.
So I'm looking for the x values, the 3 and the negative 9. Okay, so I think 1, 2, 3 here, 3, right? And 1, 2, 3, 4, 5, 6, 7, 8, 9. Way over here. So does it go something like this? All right, and let's factor this. Go back and factor this quickly and put this into 2 binomials like we were talking in the beginning. There's an x and an x because we have to do first to get the x squared. I need 2 numbers that multiply to be negative 27 and add up to be positive 6. Give me some factors of 27.
1 times 27.
Good. If I added 27 plus 1, I get 28. Is that 6? No. If I take 27 minus 1, that's 26. Is that 6? No? Give me another set of factors for
3 times
27.
9.
3 times 9. If I add 3 and 9, I get 11. Is that good? No. But if I subtract 9 minus 3, don't I get 6? Okay, so I would like to see an x minus 9 here, or an x plus 9 here because it's positive, and an x minus 3 here. So I get negative 27 on the tail, and I get a positive 9x minus a 3x, which is 6x. Fair enough? All right, if this is placed equal to 0, then each of these, according to the zero multiplication rule, the zero property multiplication rule says that I get to take x plus 9 equal to 0, because this would have to be 0 times that to be 0, or this has to be 0 times this to be 0, or they both have to be 0 times 0. So x plus 9 equals 0 and x minus 3 equals 0. If I now subtract 9 from both sides, I get x equals minus 9. And if I add 3 to both sides in a simple equation I'm solving, then I get x equals 3. Does this match up to you? Are you seeing it? And does this match up to you? Fair enough. What property did we apply here? Everybody say 0. I forget the official name and I change it every time. It's the zero multiplication property. If you multiply 2 items together and they equal 0, one or both must be 0. And that's why we were allowed to put this equal to 0 and this equal to 0. Not just allowed, but required. The zero property rule. Say that. Okay, very. Do you understand why this point can also be called a 0? And this one can also be called a 0? Does that make sense?
Mhm.
Because we used this to produce them. And so that name actually does make sense. You got to kind of know the whole mechanics of it, right? For your brain to go back through the whole process. So x-intercepts make sense because it's crossing the x. Zeros make sense. And then roots makes the least sense to me. But roots is another acceptable name. Okay, good.